So in the last video, I had some compiler issues, and I ended up just rolling back to I was using 1.4.21, and for some reason that was not getting along with the latest version of IntelliJ. It seemed like the compiler couldn't disambiguate between, it was the customs questions test, or hang on a second, the customs group. The compiler was getting confused because there's two different methods for flat map, and for some reason it wasn't able to disambiguate between those. And so I rolled back to that previous version, but then I found that in my passport test, is it this one? It's one of these tests here that it wasn't able to find. There's a method called min or null, and it doesn't find it. And so I had to switch to using min. Min is deprecated, and it says use min or null instead. And if you look, min or null is here. So I don't know why it's not able to resolve that. I have a feeling there's some kind of discrepancy between IntelliJ and the latest version of Kotlin, but I just resorted to just using the deprecated method for now until they sort this out. It's what happens when you're on the bleeding edge. So that's what I did, and it's compiling for now. I don't like that this is deprecated, but I'll fix it later. So just push a later commit. Anyway, on to day 7. Handy haversacks. Haversacks, I guess is what you call that. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules your puzzle input are being enforced about bags and their contents. Bags must be color-coded and contain specific quantities of other color-coded bags. Apparently nobody takes nobody responsible for these regulations considered how long they would take to enforce. Following rules: red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain 3 white bags, 4 muted yellow bags. These rules specify, what is muted? Is that a color? Oh, every faded blue bag is empty. Every vibrant plum bag contains 11 bags, and so on. So you have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? In the above rules, the following options would be available to you. A bright white bag, which can hold your shiny gold bag directly. Okay. And then anything that contains this bright white bag, probably. A muted yellow bag, which can hold your shiny gold bag directly, plus some other bags. A dark orange bag, which can hold bright white and muted yellow bags, either of which could then hold your shiny gold bag. A light red bag, which can hold your bright white and muted yellow bags, either of which could then hold your shiny gold bag. The number of bag colors that can eventually contain at least one shiny gold bag is 4. How many colors can eventually contain at least one shiny gold bag? The list of rules is quite long. Make sure you get all of it. So we have to basically parse out these rules here. Okay. So I want to run through this example real quick. So a bright white bag can hold it directly. A muted yellow bag can contain 2 shiny gold bags. Contain it directly plus other bags. And then we basically start with the gold bag and we work our way backwards. So in this example, the number of bag colors that it can eventually contain. So the dark orange bag can hold bright white and muted yellow. So the bright white one can hold the shiny gold bag. So how many bag colors can eventually contain at least one shiny gold bag? The data structure that immediately comes to mind is a tree, and then the root would be we build the tree based on the root that we're looking for. So the gold bag would be the root, and then the branch from that would be this bright white bag that branches directly from here, and then this would also branch off here. We could ignore the counts, I think. Doesn't really matter as long as it can just hold one of these bags. They may change that in part 2, but for now we could just treat this as a tree, and then these items could be just hung off that tree like ornaments because it's Christmas. Okay, so we can run through here. The thing is, like, what do we do with something that we haven't seen before? So but I think the tree makes the most sense. So we'd like, are they always going to start with a gold bag? I think we can't assume that. So we'd have this be some kind of node ID on our tree. And then, I don't know, if we needed to, we could have a count, like another parameter on the node that has the count. And then you just work your way down the tree. I guess we could build the tree and then be agnostic about the root of the tree, because maybe it's let's say the root of the tree is a light red bag, and then the other bags branch off of that, and then the gold bag is somewhere along that branch. Well, what we could do is just find the gold bag in the tree and then work our way back up to the root, and then everything along those lines we would count as a unique kind of bag color. So why don't we try that? Why don't we take the tree approach? I can't think of anything else off the top of my head right now. So we'll save this input. We just have to be able to parse this out. It's really like the initial, like it starts off with the color. We could just have a regex that parses out this, anything before bags, and then anything here. So muted yellow, and then the count, right? So there's a little more sophistication to how we parse this, but it's not too bad. Day7.txt. And I'm going to find some library. I'm sure that I usually use Google Guava. I'm going to go ahead and copy this real quick to the day7 full.txt. Yeah, so usually Google Guava is my go-to library for stuff like this. I'm sure they have some kind of tree implementation. Oh, it doesn't have a tree traverser. Views elements in a type of tree. The other approach would be to just have a map, and then you'd have a map of keys to a list of, you'd have like colors, and then you'd have a map of one color to the colors that it can hold, and then you just iterate over those that might be easier. just brute force it, have a map. You'd have a map of color to list of color, and then you'd just iterate over the keys, or iterate over the value set, and then whatever, if there's a gold bag in there, you'd just output the, except you'd have to work your way back up, though, is the problem. So if you had like a blue could hold a red, could hold a gold, you would still have to work your way all the way back up. So I still think the tree is probably the best way to go, because there's when you've reached the root. So let's go with that approach. Okay, so first what I'm going to do is just build like a really bare bones tree. I'm just going to take this single line. I like to start really simple with stuff like this. Actually, with everything. Just start with the simplest case possible and handle that, prove it out, and then scale up. I'm going to create a Kotlin class for testing bag test, I guess is what I'll call it. Create a function, so create base tree, and then my input is going to be this. I think I'll start off writing the parser for it. Say parse line, and then the line is going to be this string, and essentially what we want to do is we could probably write a regex for this. And then it would just contain like one or more thing with a number or no other bags. And then we'd use that to just pull out the matches. Is there a better way to do that? I guess you could search for commas in the string. You could split the string based on this contain here, and then you could iterate over this. So I think I might chunk this into two different approaches, where the first thing is to get this color here. So I'm going to call this root color. And this will I'm just going to have this be a string, and this is just going to, like, if you give it this input line, it'll just return light red. And I'm going to set this up to actually just be a parser test. This get root color, it's going to be input line dot find. Can I just do find? Is there a way to just do a regex? Do substring from regex. Finds the first match of a regular expression, so it gives us if you have a char sequence. Oh, hang on. Input string regex.find. Okay. Yeah, I'm gonna make my regex equal to, so we want basically the start of the line, right? So this caret representing the start of the line, and then this can be A through Z, because everything is lowercase, and we could always sanitize the input to make sure it's lowercase. So we're just going to search for A through Z or spaces, and then it just can't be bags. Dot to regex. And we do want a space here. So A is like, there's going to be a set of A through Z with spaces, and then another space that's bags here. And then we're going to pass in our line, and then we're going to replace. What does this give us? Regex. I think it's a list of things that it found, right? Find that value, and then we want to replace bag with nothing because we just want the color. I'm going to return this, and then get root color. I'm gonna change this to line. Get root color line should be light red. Didn't like it. Okay. So it said light reds. Oh, that's right. So we want to. What? It must have. It almost looks like it parsed this S out for some reason. Why is that? Oh, bags. Bags. That's why. I see. I see. Okay. So we need to replace bags with nothing. Okay. So that worked. We got the root color. And then we want to get the second half of this. And it looks like there's another potential value for this where it says contains no other bags. And we want to handle that case. So what we should do is get, I'm going to write a method that is get contains bags. And this is just, I'm not going to worry about the count for now. We'll put a pin in that just in case we need to. It doesn't say that we need to worry about it because it just says at least one shiny gold bag, so we don't really care. So I'm just going to make this be a list of colors. And it's fine if this is private. I think that's what this compiler is complaining about. We'll make it private. This will return a list of string, and then it'll return an empty. The contract will be it'll return an empty list if it's not able to find anything. So first of all, we want to check that if it says contain no other bags, then we want to just return an empty list. So that's our check initially for before we start parsing these comma separated values here. If line contains this string, return a list of empty, just an empty list. And I think Kotlin even has an empty list here. Otherwise, we can go through and we can just take this same regex, I think. Actually, we could use a similar approach. We could say contain blah, blah, blah to this. We want to just grab these strings here and then split them by commas, get rid of this number. But yeah, essentially like the next step is to just grab this second half of the string. So I'm going to do val regex is equal to, we want contain with a space, and then I think I'm going to, if I surround this with parentheses, then it will give me a group of regexes, and then I can just pull that string straight out of there, I think. So this is going to be basically anything that's not a period, right? I'll just do a shorthand for this. Anything that's, this caret means not for regex, and then we'll do a backslash period because the period is a special character, and this can repeat. what I'm going to do, I just want to use a regex tester to double check this. My regular expression is going to be this contain here, and then we could even put a $sign in here for good measure just to capture that end of the string. And then the test string is going to be this contain no other bags, or no, not contain no other bags. It's going to be light red bags contain blah blah. Okay, so we can see that it grouped this, which is what those parentheses do. So now it has one bright white bag, two muted yellow bags, and then the period and the contain is not. So that's exactly what we want. We're gonna go regex dot matches. I think, or what did that? Regex dot find, and this gives us a match result. What is a match result? Is that and then okay, so this will give us a group. So we'll do this, a similar thing to what we did. We'll find line, and then we're confident that this exists, and then dot groups. Is there a way for us to get the groups here? Oh, dot two, I have to do two regex. Okay, so we find line, and then we do groups, and we want the groups one. And we could just do dot split, and we're going to assert that that's there, and then we want to split this string. Why is that not, what is this giving us? This is a match group. Dot value, I think, is what we want. So we're going to find this, dot value, and then what we want to do is split it. We're going to split it on the comma, and then we can loop over this and just cut out this number here. And then return the value. Now, is this a regex? Can I use a regex? Okay. We're going to replace things at the beginning of the string that are digits. I think that's how you do digits. Let's double check. I'm gonna copy one bright white bag. So we basically want to have digits repeating, and then the space after that. We could always just trim it. We could just do a dot trim here. And I think replace returns the string, doesn't it? Double check. Anyway, this one bright white bag, we want digits repeating until you have a space, and only at the beginning of the string. Okay, so that's what we want. Digits repeating, beginning of string, replace it. So now we don't really need this trim here because it's already effectively trimmed for us. And we're going to replace it with this. And I think it needs to have a regex for this. I'm going to replace regex, and replace returns the string, so that mapping will work. So I'm just going to do a return here, and we're just going to test this. Val contains is this, and we want to do get contains bags from this line. I'm gonna rename this contains bags because there's a Kotlin method contains that I don't want it to get confused with. So contains bags dot contains bright white bag should be true. And it should also contain muted yellow bags. Okay, so this is another, actually, we need to do another replacement. We need to replace bag or bags at the end of this string. So I'm going to map it.replace this, it.replace, and then at the very end of the string we're going to do a space with bag with a possible S, and in a regex the question mark. It's 0, 0 or 1, I think is what it stands for. And then that's going to be at the very end of the string. And I'm just going to test that. Sure enough, it picks up bag here. So we're going to do the same thing, replace this regex of bags with nothing. You get nothing. Okay. So now this should be bright white. This should be muted yellow. How much time? As usual, it seems like these advent of code problems mostly are, like the thing that takes forever is just the parsing the input, and then the actual solution isn't too bad. In this case, this one might be a little more complicated, but we'll see. So I also want to check that contains bags.size is 2, right? So this should be only an array of 2 things, white and yellow. And let's do it. Let's try it out. And then the next thing I want to do is write a test for something that contains no other bags and make sure that that handles correctly. And that blew up on us. Expected true but was false. Muted yellow. So what happened here? What does contains bags have in it? Contains bags is a size. Oh, so it didn't actually parse out that. Weird. Okay, so for some reason this digits thing didn't pick up this 2 muted yellow here. Why is that? Let's find out. Oops, we want to put this in the test string, and then we want to do this replacement here. Yeah, so that should have worked. I don't know why it didn't. So I'm going to run through, make sure that this is correctly. So this is the bright white bag, and then we want the yellow one. 2 muted yellow bags. Okay. Oh, interesting. There's a space in between here. That's why. So what I'm going to do first is trim it. I want to trim this input and then do this replace. And then we're essentially guaranteed that these regexes will match. Okay, so this should pass now. I'm going to cancel that. Stop running this. Okay, so that parser test worked. I'm going to write a second one that does that's for that line where it says contains no other bags. And then we need to figure out how we're going to add these to a tree. With contains no others. And then we want to just make sure that this one is 0, and let's run it. It should work, because we had that if condition in the beginning that, no, it didn't work. Actual dotted, oh, dotted black. What happened? Dotted black bags contain no other bags. Maybe the regex might have gotten greedy and picked up on this bags here at the end. Yeah, that's probably what happened. Is the regex, this one got a little bit too greedy, and it picked up the last occurrence of this. So I really want this to pick up the first one. Maybe what I'll do is I'm going to use contain as my word. Actually, we can use bags contain, right? That should work. That'll pick up. That'll force it to pick up that first one. Didn't like that either. Oh, because it picked up this whole thing. We actually want, what if we just did this? We could use a grouping like this that we did before. This grouping, and then we just do, we'll use this, we'll find it, we'll use these dot groups, groups one, dot value, and then we don't need to do any replacement. We will trim it though, just in case it picks up an extra space there, because the regex is searching for spaces. That passed, okay. Perfect, and let's just make sure that the other one passes too. Oh, yeah, that's fine. Okay, so now we're parsing that input correctly. And we want a tree now. So let's find a Kotlin tree library that we can use. Tree walker. I'm just going to open a few of these. And I'm picking tree because I'm assuming that there can't be cycles. Like you can't have like a red bag that contains a blue bag that can contain a red bag. It's just an assumption. The assumption is that these bags they're going from largest to smallest here, but important to note that assumption. Oh, I see. So it's obfuscated. I was wondering why this is not in English. I know what a tree is. I just want a library that I can use for trees. Oh, so Kotlin maybe has one built in. That's cool. Oh no, this is a JavaScript node. Okay, never mind. And I also don't really want to build my own. I just want to use one if it's out there, because I know how it's going to work. I know this is probably super exciting for anyone watching this. to just see me looking up these data structures. But it looks like this might be promising here. I guess there's also a possibility that we might have multiple root nodes. Like you could have like a red bag that can contain these other kinds of bags, and then maybe a different bag that can't, or that contains other ones. So you could have this tree over here and this tree over here that have different kinds of bags. That's another possibility here. I wonder if there's an easier way to do this. I'm going to bring my desk down because I've been standing for a little bit. Because I am a little bit concerned about the multiple kinds of, like if we had multiple trees, potentially. Let's take a look at this real quick. So light red bags contain one bright white bag. There's a way to draw a mind map. Okay, so let's say we have our root here, and then we have light red, and then that can contain a bright white, muted yellow, and then dark orange can contain bright white, muted yellow. And then muted yellow can contain shiny gold, faded blue. Shiny gold contain one dark olive. Vibrant plum. Dark olive can contain faded Look at that though. Check this out. There's kind of a cycle here. I mean, it's not really a cycle because this is a different branch, but so faded blue and then dotted black. Faded blue bags. Hang on a second. No others. Did I just read something wrong? Shiny gold bags, faded blue. Faded blue, dotted black. Yeah, I misspoke a second ago there. Vibrant plum can contain faded blue and dotted black. And then faded blue can contain no others. So in this case, we do have two different trees here. So you have dark orange as a root node. I almost think that we could just make a map, right? You could have a map of, you could start off with a map of dark olive to these two, shiny gold to these two, and then you could take all the keys. You could find the ones that have no, the root nodes are going to be the ones that have nothing else that has them as a parent. And then you could just sort of iterate up the chain here. So if we're looking for shiny gold, we would do we could actually map I wonder if it'd make more sense to map these to their parent. So faded blue can map to dark olive or muted yellow. And then if you have a parent that maps to null, then you're done. So shiny gold would map to muted yellow would map to light red maps to nothing, and so you're done. And yeah, so why don't we invert this tree? We could invert the tree, just save it as a map, and then the map will be the children to all possible parents, and then you just iterate over the map until you have a tree until you have an item that has no parents. I think that'll just be a little bit easier. I'm going to parse the input. I'm going to have a different method. Parse. Yeah, it doesn't matter. I think this will read the file in and then read the lines and then parse it to a map of string to. It'll be a string to list of strings because we're mapping it to a list of possible parents. Okay. And now we want to do, we want to get this buffered reader. Pass in the file name as a string. We're going to read the text. We don't need to worry about splitting it because we can actually just do read lines. And then for each of these, we're going to map it. Right. I think I might need to have a mutable map at the top. It's going to be a mutable map of string to list of string, which is what we want. And then it'll be mutable, but then I'll return it as an immutable map. Okay. So for each of these lines, what I want to do is grab the val root color is the get root color of it, which is the line. And then I want to do val children is get contains bags for it. And then what we're going to do is we're going to add an entry for each of these. I'm actually going to do I'm going to make this a variable for each line. That way I can use it in a different method down below. So get root color for this line, get contains bags for this line, and then for each of these, I'm going to do color map dot add The thing is, I need to check if it already exists. If it does already exist, I want to add it to the list. So what I want to do is add it to the map, add a list of it to the map, but if it already exists, then I need to compute it. I think this compute if compute. Okay, sweet. So it gives me a by function that that will let me do that. Okay, so for each of these, I want to compute root color, which is the key, and then there's a by function. I think I can do this Kotlin convention. We want to compute this is not happy right now. I think it needs to have this key value. Is that going to be happier? I'm going to map this key to value to mutable list add. And we're not going to compute the root color, we're going to compute it. So that we want the key. The key is the child color, right? The child to a list of all its parents. The thing is, we need to default this to an empty list, right? So how do I initialize this? I think I'm going to do a check on this map. We're not doing any kind of, this doesn't need to be atomic because we're not doing any kind of concurrent operation here. But what I might do is color map. Oh, I still need to get the colors. It contains bags for each. We need to initialize this. So color map it dot compute. I'm going to do compute if absent first, and then it, and then I want just an empty list. I don't know why this is complaining. So basically what I'm trying to do is take this, for each line, I get the root color, and that's the parent, and I want to add the parent to the list of the children's colors. but I don't know that this has been initialized. And so if it hasn't been initialized, I need to initialize it to an empty list. Let's try this first, just to make sure that this is actually... I'm just trying to get the compiler to stop complaining. I've just been wrestling with the compiler all morning. Is it complaining because I'm returning a list out of here? And it's... So type inference failed, expected type mismatch. Get contains bags. It's a list of string. Oh, it's not returning this map. I see. I'm just going to make this, for now, I'm just going to make this a unit just to get this to stop complaining. Is that what it was? No? Can you just refresh this, IntelliJ? Okay, so now it's, okay. I see. I think I can just do this in one method. Okay, so color map.compute. So basically what I want to do is check if the value is empty. I'm going to put this in parentheses. So this will initialize the value if it's empty, and then we're going to convert it to a mutable list. And then we're going to add the root color. And I think I might actually make this a set. Oh, key is never used. Okay. So I'm going to do key to this dot to list to set. Didn't like that. I think add might be a... Oh, add doesn't actually return anything. Key to... I'm just gonna... val, this is super frustrating. Mutable. Or I'm gonna say new val. New val is this. Equals this. To mutable list. New val dot add root color. And then I want to return key to new val. Yeah? Is that gonna work? I don't know why that's complaining. It looks like the same kind of... Is that it? By function. That's a V. So it wants the value. Okay, so I'm returning that. Why are you... Oh, it's to mutable list. I see. Dot to list. I was returning a mutable list when I was expecting a list. I might just do a set though. I'm gonna make this a set of string, just because we only want unique parents in here. New val dot to set. Is that gonna work? And we need to make this an empty set. To mutable set. God, I am just wrestling with my tools today. Come on. required set of string. It found a function that gives me a set of string. Oh, do I? Maybe I don't actually need these. I don't need this block. There we go. Okay. So that remaps it. So let's just make sure that this is sane. This is what we expect. So now we should have a list or a map of the children to a set of all their potential parents. And some of these should be empty sets. Do a test for the example input. Parse input, and then the file name is going to be day7.txt. And then I'm just going to print it out, and then I can set a breakpoint. Println parsed. Here's my breakpoint. Let's run it. God, this is the same compiler thing I ran into earlier. I don't know why IntelliJ is having issues with this after I rolled back. Yeah, this is just not working. I think I'm gonna comment this out for now. I've already solved this day, and then fix this. I'm just gonna say compiler issue and move on. Maybe IntelliJ will push out a new update or something in the next few days, but I've already done it, so I don't want to worry about it right now. So parsed is shit. We need to return that color map. Return color map .to map, which will make it immutable. And then we need to change this method to have a new return type. Oh, it's returning here. Okay, so now that's building the map successfully. And we'll stop this, rerun it. So yeah, now what we want is to have a map of the children to a set of their parents. And let's just make sure this makes sense. So we have 7 different colors here. Just looking at that mind map, let's see. 1, 2, 3, 4, 5, 6, 7. I mean, these are the children. The faded blue has no children. So I think that makes sense. We shouldn't see faded, or we do see faded blue here. Oh, because it is a child, but there's no children of faded blue. Okay, so bright white can have 2 parents, light red and dark orange. Bright white can have light red and dark orange, sure. Shiny gold can have 2 parents, bright white and muted yellow. Muted yellow, and then bright white. Okay, yeah, I can do that. So yeah, just a sanity check, this seems to work. And now I think what we want to do is just get the shiny gold and then take these parents and then just walk up. So we want to take muted yellow, and then we'll look in the map for muted yellow. We'll find light red and dark orange, and then we'll look at dark. And then we'll search the map for, right, we'll search the map for light red. We won't find it. We're done with that one. And then we'll search for dark orange, not in the map, so that nothing has it as a child. So we're done in that case. So we can just basically walk over this map, and then for each item in the map, walk our way up. And this might be an area where recursion comes into play, because we're recursively walking our way up the tree. We actually kind of have an inverted tree, and the tree is actually we actually have several trees, and we just want to walk down until those ones are null. I need to think about how to do this. I might end up making a second video because I'm already at an hour and I'm getting kind of hungry for lunch, but I think I'll go for another 15 minutes, see if I can't figure this out. So I'm just going to do this manually for now and then figure out a way to factor this into something more sensible. So parsed. I'm going to just make a private const val shiny gold constant. Shiny gold is shiny gold. Parents is this, so this gives us the set of parents. I might just write a method that is traverse tree at node, and then what that does is it just gets we'll pass in the visibility of the tree. We basically need to get every node that has children from there. If we're inverting the tree, whoops, I didn't save it. But essentially we're inverting the tree. And so the root nodes are the children. And so we need to traverse all the way down, get everything that's down below those child nodes. So if we traverse the traversal will give us a set of string. The set of every node that is below that node. So the root is going to be this string. And that might be all we need. So the base case is going to be, we also need the tree. Oh, a string to a set of strings. Okay. And now, if the tree If the tree does not contain the key, we'll say node. We'll call this node. If the tree does not contain this node, we're going to return an empty set. Otherwise, we're going to keep traversing. We're going to get the parents, or we're going to get that node's children, and then traverse those. And union all those together. We're just going to assert that that exists, but let's see. No, we're going to assert that it's not null. Dot, and then we're going to just do we'll map it. Traverse it. And tree. So we're traversing the children, and then dot to set. But we need to union all those together. We'll reduce it. We'll say A, B is A dot union B. So we'll just combine all those sets together. I think that should work. So we just traverse down and make this a private function too. And then traverse. We want to traverse the shiny gold node. And here's our parsed tree. Val children is equal to this. Children dot size should be 4. So there should be 4 different kinds of bag colors that can at least contain one gold bag. Let's try this. Zero. Didn't like that. So let's walk through and see why that didn't work. So right now the node is shiny gold. The tree does not contain, the tree does contain shiny gold. So we're gonna traverse. We have bright white. Oh, but we're never actually returning anything. We're never actually returning the value of the. What we want to do is have a set of. We want to combine it with the set that we have. So the current set is going to be this tree.node. And what we want to do is combine it with this dot union with the current set. Yeah? Should work. Let's try that. And sure enough, it's 4. Okay. So now I think we're ready to go to the big league here and try this on the full input. I'm going to change this just to be consistent with my naming scheme for these other text files. K7- full. We're going to traverse, and then I'm just going to we're going to print ln children.size. And I want to just take a look at this, what it parsed out, just to see how many items were in the tree. So we had 416 items. Children were 370, so there's 370 possibilities for. That's the right answer. Cool. Okay, so now what are they going to throw at us? It's getting pretty expensive to fly these days, not because of ticket prices, because of the ridiculous number of bags you need to buy. And first I'm going to do children.size should be 370. Because of the ridiculous number of bags you need to buy, consider again the shiny gold bag and the rules from the above example. Faded blue bags contain 0 other bags. Dotted black bags contain 0 other bags. Vibrant plum bags contain 11 other bags. Faded blue bags. So they are going to work in these numbers. So a single shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plum bags. The actual rules have a small chance of going several levels deeper than this. A shiny gold bag must contain 126 other bags. I see, so we have to assume that these are full, these bags are being contained. How many individual bags are required inside your single shiny gold bag? 1 dark olive bag and those 7 bags within it, plus 2 vibrant plum bags. So this might require a different traversal. So we traverse up to the parent. And then the parent has, so we might need to map the parent to the children with the counts of the number of children for that bag. And then as we're traversing up, we keep track of the count as we're doing that. So I think we could just invert this tree, invert it so we have the parent nodes mapped to the children mapped to the parents, and then as we're traversing up, we keep track of the count of bags that are siblings of the gold bag. I think that'll work. I'm getting hungry for lunch though, so I'm gonna separate this out into part 1 and part 2 and just commit what I have so far. So I will see you in the next one.